Have you ever been driving down a highway and noticed long cracks running across the concrete? Maybe you've wondered if the road is falling apart or if something went wrong during construction. After all, concrete is one of the strongest building materials we use, so why does it crack at all? The answer is surprisingly simple. Cracking isn't always a sign of failure. In fact, engineers often expect concrete to crack, and they design highways around it. Today we'll uncover why concrete highways crack, what causes those cracks, and how modern engineers keep roads safe and durable. Right here, on History of Simple Things. Concrete has been used for thousands of years, dating back to ancient civilizations like the Romans, who created durable structures using volcanic ash mixed with lime. However, modern concrete highways didn't appear until the early 1900s, when automobiles became more common and roads needed to handle heavier traffic. One of the first major concrete roads in the United States was built in 1909 in Detroit, Michigan. Engineers quickly discovered that while concrete was incredibly strong under compression, it had one unavoidable characteristic. It naturally developed cracks over time. Instead of trying to eliminate every crack, road designers began developing methods to control where cracks appeared, making highways safer and longer lasting. One of the biggest misconceptions about concrete is that it's indestructible. In reality, concrete is extremely strong when being squeezed, but it's relatively weak when being stretched or bent. Imagine snapping a dry cracker. It can support some weight when lying flat, but bend it just a little too far, and it breaks. Concrete behaves in a similar way. Highways experience constant forces from heavy trucks, buses, and millions of cars every year. Even though each vehicle may only flex the pavement by a tiny amount, those small movements add up over decades. Eventually, tiny internal stresses become visible cracks. Temperature is one of concrete's biggest enemies, and also one of the main reasons highways are built with expansion joints. Concrete expands when it heats up and shrinks when it cools down. During a hot summer afternoon, a concrete slab can become much longer than it was during a cold winter morning. If the pavement had nowhere to move, the built-up stress could cause large, unpredictable fractures. That's why highways are divided into separate slabs with carefully placed joints. These gaps allow each section to expand and contract independently. Even with these joints, small cracks can still develop because weather changes happen thousands of times over the life of a road. Surprisingly, many cracks begin forming long before the first car ever drives on the highway. Fresh concrete contains a large amount of water. As it hardens, a process called curing, some of that water evaporates while the cement chemically reacts with the remaining water. This causes the concrete to shrink slightly. If the shrinkage happens unevenly or too quickly, internal tension develops. Since hardened concrete doesn't stretch very well, tiny cracks can appear. Proper curing techniques, such as keeping the surface moist during the first several days, help reduce these early cracks, but they cannot eliminate shrinkage entirely. A highway is only as good as the foundation underneath it. Before concrete is poured, engineers carefully prepare layers of compacted soil and crushed stone called the subgrade and base. If these layers settle unevenly over time, parts of the concrete slab lose support. When heavy trucks pass over unsupported sections, the concrete bends slightly more than intended. Repeated bending eventually creates fatigue cracks. In areas with clay soils, seasonal moisture changes can cause the ground to swell and shrink, adding even more stress to the pavement. Most highway damage isn't caused by passenger cars, it's caused by heavy trucks. A fully loaded tractor trailer can weigh up to 80,000 pounds, or about 36,000 kilograms in countries using the metric system. Every axle presses enormous force into the pavement. One truck doesn't usually cause visible damage, but highways may carry millions of truck trips over several decades. Each pass creates microscopic fatigue inside the concrete. Eventually, those tiny changes accumulate until visible cracks form, much like repeatedly bending a paperclip until it finally snaps. Seeing a crack doesn't automatically mean the highway is unsafe. Engineers classify cracks based on their size, location, and cause. Hairline cracks are often harmless and may never require repairs. Some cracks are even intentionally created using saw cuts shortly after the concrete hardens. These controlled joints encourage concrete to crack in predictable locations instead of randomly across the pavement. Maintenance crews regularly seal certain cracks to prevent water from entering beneath the road. Keeping water out is critical because moisture can wash away supporting soil or freeze during winter, expanding and making cracks much larger. So, why do concrete highways crack? It's simply part of how concrete behaves. Temperature changes, natural shrinkage, heavy traffic, and movement beneath the pavement all create stresses that concrete cannot completely resist. Rather than fighting nature, engineers design highways to manage these forces by using expansion joints, reinforcement, strong foundations, and regular maintenance. The next time you're driving across a concrete highway and notice those familiar cracks or evenly spaced joints, you'll know they aren't necessarily signs of poor construction. In many cases, they're evidence of smart engineering at work, carefully controlling where concrete moves so the road can safely carry millions of vehicles for decades. Sometimes a few well-managed cracks are exactly what keep an entire highway standing strong. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.